Welcome to this section in Learning ElasticSearch 6 entitled Machine Learning and ElasticSearch 6. In this section, we kick things off with a brief introduction to machine learning. Next, we dive into the specifics of how machine learning is done in ElasticSearch. We conclude things with a walkthrough of a machine learning job. It's a single metric machine learning job. Intro to machine learning. What is machine learning? Here's a definition according to Arthur Samuel, a pioneer in the area of computer gaming and AI. Simply put, machine learning is the field of study that focuses on computers learning without having to be explicitly programmed. Think feeding a lot of data to a computer and having the computer derive understanding about that data so that it can draw conclusions when similar data is seen. In this video, we're going to focus on three of the most commonly implemented machine learning tasks. First, the machine learning task that learns from what is called labeled data is known as supervised learning. Labeled data is structured with columns and rows along with headers for each column. Sometimes, that is. Those of you from the relational database world should be all too familiar with structured data. Supervised learning is used to determine relationships, linear or nonlinear, or to classify data into groups. Supervised learning is often effectively used for making predictions. Contrary to the organized nature of structured data, most of the data today lacks the labels. This is where unsupervised machine learning comes in. Unsupervised machine learning analyzes unstructured data, such as web logs, to determine patterns, anomalies, and more. ElasticSearch uses unsupervised machine learning to analyze data. Finally, semi-supervised machine learning is the area of machine learning that uses both labeled and unlabeled data to create models. It falls squarely between supervised and unsupervised learning, needless to say. Machine learning has different modern-day use cases, from image recognition to natural language processing. Three of the more common use cases for machine learning are anomaly detection for security or credit card fraud, predictive analytics for, say, predicting the price of a house based on previous data, or the grouping of similar things is a common machine learning implementation known as clustering, or better known as population in ElasticSearch. This is good if you wanted to cluster customers based on similar traits for marketing purposes. The ElasticSearch implementation of machine learning is great because it makes the process of model building easier by abstracting away from the complexities of machine learning statistical modeling. It has a highly intuitive user interface, as we'll soon see. Feeding data to a model or building a model can be done quickly and easily. Most important, the machine learning implementation works well with ElasticSearch. Machine learning is complex and can involve many steps, ranging from data cleansing to the complex splitting of data sets to test and train the model. As we'll see in our upcoming examples, ElasticSearch removes a lot of these pain points. In our example, first we'll need to get the data. Next, we'll need to use machine learning features from ElasticSearch 6 to train the model with our data. And finally, we will understand how to run data through the model, which is called feeding data. More specifically, we'll get the data we want to use to train our model. The data we'll be using will be from a simulation. We'll simulate weblog data. Next, we'll create a job. This involves several steps, which includes selecting bucket sizes, where smaller buckets better generalize the model, while larger buckets make the model fit the data better. Balance is essential. We then move into training the model, where we'll actively see a visual representation of the model training process. And finally, we'll look at the scheduler, which allows us to either feed data continuously or for a set duration of time. And that concludes this video.